SCL Group 2. We are going to present our CL calculus project. I am Hussein. My matric card is 186638.
I'm Zakasha bin Azahari. My matrix number is 190523.
I'm Naraza Binti Ahmad. My matric number is 19027. I'm Nurfala Binti Mundi. Matric number 190324.
My name is Chun Ziling and my matric number is 187734.
Okay, for the assignment that we get question 2. The question is, if all the materials is used in the construction process of a box in which it has a square base, then determine its maximum volume provided that 10 meter square as material building.
Okay. From the question, we know that the material we have now is 10 meters square, which is the area of the material we have. And now we want to find the maximum volume of the box with square base. So first we need to draw the box first, the box with a square base. The base is square, so that means the width and the length is equal to x. Let's say the width and the length is equal to x, and then the height is h. So first we want to find the maximum volume, right? So we need to know the formula of the volume. For the volume of the box is width times length times height. So the width and the length is x, right? So x times height. So x square h. And then from the question, we know that the material we have, the area of the material we have is 10 meter square. So that means the total surface area of the box is 10 meters square. So formula for the total surface area is the bottom, that means is square x square, but we have two square part, the bottom and the top. So we need to x square plus x square and then plus the four side part, which is the area is x times h, so this will equal to 10 meter square, and then we simplify it into 2x square plus 4x h equal to 10. Okay, from this formula we can find that the h is equal to, we shift this 2x square to the right side, so will become 10 minus 2x square divided by the 4x. Okay, this is the value for the h, and then we need to substitute this h value into this formula, this h, because we need to find the maximum volume. Okay, so v equal to x square times 10 minus 2x square divided by 4x. Okay, so just simplify it. 10x minus 2x square times x cubed, and divided by 4. Okay, this is the simplest form of the volume. And then the next part is we need to find width. We can also simplify it. This equal to 1, and this equal to 2, and this equal to 5. So the final answer will be 5x minus x cubed divided by 2. Okay, the next step is we need to find the first derivative of volume. Since we want to find the critical point of the volume, so first v equal to 5x minus x cubed divided by 2. So the dv dx will be 5 squared. Okay, this equal to 5 over 2x minus x cubed over 2. Okay, so this will equal to 5 over 2 minus this power 3 shift to the front, so 3x squared divided by 2. Okay, this is the first derivative of the volume. And then if we want to find the critical point, we can find the critical point when the dv dx is equal to 0. So 5 over 2 minus 3 over 2x squared equal to 0. You just do like usual, shift this 5 over 2 to the right side, so negative 3 over 2x squared equal to negative 5 over 2, and then this negative 2 shift to the right side. That means 3x squared equal to negative 5 over 2 times negative 2, so cancel it out, and then this 3 shift to the right, so equal to x squared equal to 5 over 3, and then the square you shift to the right will become x equal to plus minus square root 5 over 3. Since the critical point will be only positive, so the final answer for the critical point will be square root 5 over 3. Okay, so this is the critical point, but now we need to prove that this critical point is the maximum point, so we need to show that the second derivative. So from the result just now, the first derivative is 5 over 2 minus 3 over 2x squared, and then the second derivative will be negative 3 over 2, 2 shift to the front, 2, and then x, so the answer will be negative 3x. Okay, so and then you substitute the answer just now. The answer just now is x equal to square root 5 over 3, isn't it? So you sub this value into the second derivative. It will become negative 3 square root 5 over 3. So from this you know that the answer is negative, right? So negative, this shows that the critical point is maximum point. So we know that the volume at this x value is maximum point, is maximum volume. So we take this x value and substitute into our maximum volume. Our maximum volume is v equal to 5x minus x cubed divided by 2. So we substitute the x value into the volume, 5 multiplied by square root 5 over 3 minus square root 5 over 3 power of 3 and divided by 2. And then the final answer you get will be 2.152 meter cube. So this is the final answer for the maximum volume. Thank you.